All right, hello everybody. So today we are going to start into chapter 3, section 3. And what you're going to find is we're going to be using some of the stuff that we've learned in the last couple sections to continue to discuss polynomials and ultimately break those down into what are called linear factors and then be able to graph those. So we touched on how to graph a quadratic. With taking something and completing the square to put it into vertex form. And so as that process is a great process, but it's only just for quadratic equations. And what you're going to find is in Algebra 3 or advanced algebra, there's a lot other types of equations than just quadratics. There's cubics, there's quartics, quintics. Anything beyond usually cubics, we actually just call polynomials, which means many. So we're looking at various types of polynomial functions and how we can go about graphing them ultimately. And there's quite a bit of processes involved to get a polynomial equation broken down into a state that allows us to be able to gather enough information to then graph it. So that's what I'm going to begin to show you. So as you can see, we're going to work on polynomial and synthetic division. So synthetic division, I don't think you guys did last year, but I believe you did long division, which is what we're going to focus on today. So this is what I'm talking about. We have this polynomial function you can see right here. In this case, it would be a cubic function because the highest power is 3. But it's 6x cubed minus 19x squared plus 16x minus 4. Now, the process to graphing these is going to be as follows. What we're going to do is we're going to take this polynomial and we are going to break it down into its linear building blocks as much as we can. And what those linear building blocks, otherwise known as linear factors, are going to do for us is they are going to allow us to see where this particular function crosses the x-axis. So as you can see, if we zoom in on this graph a little bit, there are actually 3 different places where this thing crosses the x-axis. Now, that would actually make sense because this is a cubic, that means we can have up to 3 x-intercepts. And in this case, we do have 3. Now, where the x-intercepts are going to help us is if we know what the x-intercept is. In this case, we're going to go for the easy one, which is over here. And we can see that x is equal to 2. If we know where the x-intercept is, then we can figure out at least one of the factors that was used to make this polynomial. So let me give you a little simpler example. If I take the number 12, okay, and you guys learned how to do this quite a few years ago, I'm going to break 12 up into 2 times 6. I'm going to circle 6 because 6 is prime. I'm sorry, not circle 6. I'm going to circle 2 because 2 is prime. But then 6 is going to break down further into 2 times 3. And then once I circle all 3 of those, you can see I now have what is called the prime factorization of 12, right? So 12 is equal to 2 to the second times 3. These polynomials are built the same way. What they are is they are the product of a multiple of linear terms that were all foiled together to give us this. And so our job now is going to be to break those polynomials down. The way we're going to do that is using our different factoring techniques. But what I'm showing you here is that if you know something crosses at an x-intercept of 2, then the factor is x minus 2. Okay, so the general rule is if you know the 0, the reason why it's called a 0 is the y value of that ordered pair is 0, then the factor of this is going to be x minus the 0. So in this case, the 0 was 2, so the factor is x minus 2. And what we would then be able to do is, since we know that's a factor, is we can divide that out using long division. So let me show you how to do long division with polynomials. The first thing you're going to do is set up your division problem, and you're going to write what is being divided inside the radical here. Not really a radical, the dividing symbol. 16x and then minus 4. Now I'm going to put x minus 2 right here. Now this is done just like you did long division way back in elementary school. There's a little bit of a difference though, and this is the difference. This minus 2 right here, we don't worry about what it turns out to be. So our goal here is to turn this x into each one of these terms as we go across here. So in the first part, we're going to turn this x into a 6x cubed. The way we turn an x into a 6x cubed is to multiply it by 6x squared. Now, this 6x squared right here is going to multiply this, and it's going to multiply the minus 2, and to give us a new amount that we're going to write right on that line. So let me show you how to do that. 6x squared times x is 6x cubed. Now we're going to do 6x squared times negative 2. And so when I do 6x squared times negative 2, I get negative 12x squared. Okay, so now you can see I'm lining up the like terms in vertical columns. The next thing I'm going to do is I'm going to put a set of parentheses. I'm going to put a minus sign right here. Now, this next part needs to happen in order to know that you did things correctly. What should happen is this first set of factors, or not really factors, the first term should cancel. If it doesn't cancel, you didn't get this part correct. You did something wrong. So the 6x cubed minus 6x cubed is 0. That's what we want to happen. And now we have negative 19x squared minus negative 12x squared, which gives us a negative 7x squared. Now, following that, we're going to drop down one additional term, in this case, 16x. And we're going to do the whole process all over again. I want to take this x, and I need to multiply it by something to turn it into a negative 7x squared. So I'm going to multiply by a negative 7x. So now this negative 7x is going to multiply the x, and then it's going to multiply the negative 2, just like that. And then we're going to write our answer right underneath here, right there. Okay? So negative 7x times x is negative 7x squared. And then negative 7x times negative 2 is positive 14x. I'm then going to put a set of parentheses around that second part, followed by a minus sign on the outside, just like that. Once again, we have the first term should cancel if you did this right. So I have a negative 7x squared minus negative, which would become plus 7x squared. So these two cancel. We still have 16x minus 14x, though, which is 2x. And if you notice, both of these terms here and here are being subtracted, which is why I have you put a set of parentheses around them before you do the subtraction. Now, we still need to drop this minus 4 down, like this, and we need to continue. And the reason why we need to continue is as long as you have something here that is an equal or higher power than what you're dividing by, you have to keep going. So in this case, we're dividing by x to the first. We still have an x to the first, so we need to keep dividing. What we have left has to be of a smaller degree than what we're dividing by. Okay, so how do we turn an x into a 2x? Well, we're going to multiply it by 2. So I'm going to write a plus 2 right there. 2 times x is 2x, and then 2 times negative 2 is negative 4. Put a set of parentheses around that again. I'm going to subtract, and as you can see, once again, this lead term cancels out, and I have negative 4 minus negative 4, which would become negative 4 plus 4, which is 0. Now, that 0 is important because what it tells us is that this x minus 2 divided evenly out of our original expression. But here's where the most important information comes from after doing this division. Once we know that this is dividing out evenly, We have successfully taken a linear term out of this. What we've done is we have taken x minus 2 out. And what we are left with is the answer up there, which that is 6x squared minus, let me try that squared again here, 6x squared minus 7x plus 2. Now, what you see there, if I were to refoil this x to everything and refoil this 2, not really foil, it's really distributing. But if I were to redistribute the x and the negative 2 to everything and then combine my like terms, I would get my original number, or not really number, but this original polynomial that I started with. But remember, our goal is to take what I just underlined and break it down into linear chunks. This is a linear chunk. Otherwise, it's actually called a linear factor. Okay. Now, what you see we're left with is a quadratic. Now, we have a whole bunch of ways to break down a quadratic equation. We could use the quadratic formula. We could, in this case, we'd have to use the ABC method and do 6 times 2. But there's a bunch of ways to do that. So our goal, again, is to take these bigger polynomials and start breaking out of the linear terms out of them until eventually they're completely broken down. Here's what I want to show you to do if you end up with a remainder that is not 0. So I'm just going to make one up for you. So I'm going to do x to the third plus 2x squared minus x plus 1. And I'm going to divide out x plus 1 out of that, okay? So I'm going to multiply by x squared. X squared times x is x cubed. X squared times 1 is x squared. Put a set of parentheses, and I'm going to subtract. So x cubed minus x cubed is 0. 2x squared minus 1x squared is 1x squared. Okay, I'm going to bring down the minus x. Now I need to turn this x into an x squared. So I'm going to multiply by positive x again. X times x is x squared. X times 1 is 1x. I'm going to put a set of parentheses and subtract again. I get negative 2x. Bring down the plus 1. So I'm going to multiply by negative 2, negative 2x, and then minus 2. I'm going to subtract. I'm running out of room. I'll switch to black here. You can see these two cancel, and then I'm left with 3 on the bottom. So what do you do if you have a factor? Or a remainder, excuse me. First thing to know is that means this x plus 1 would not factor out of this. It is not a linear factor of x cubed plus 2x squared minus x plus 1. How do we know that? Because the remainder is not 0. Okay, just like if you tried to do, I don't know, 10 divided by 3, right? So you would do 3 times 3. 3 times 3 is 9. You'd subtract, you'd be left with a remainder of 1. Back in the day, you were told to just do remainder 1, right? A long time ago. Then as you got better with math, they said, well, we're actually going to take that remainder and we're going to put it over what we originally divided by. So instead of writing 3 remainder 1, we write 3 and then 1/3, because that's what we originally divided by. So you take the remainder and then you put it over what you divided by. That's exactly what we're going to do here. Okay, our remainder is 3. So I'm going to go here and I'm going to write plus, and then I'm going to write 3 over what we originally divided by. So in this case, it's x plus 1. And there you go. So guys, that's how you do long division with polynomials, and that is also how you deal with remainders. So as always, if you have any questions, feel free to email me or speak up in our Google Meet. Have a great day.